You literally cannot spell research without search. It's right there in the middle.
Yeah, that's true.
And that core idea that how an AI searches for information is, well, fundamental to how it researches and gets us the answers we need, that's exactly what we're diving into today.
Yeah, we're taking a closer look at something pretty critical for large language models.
Hmm.
How they actually get current information, from the outside world.
Right.
Because,
Yeah.
and this surprises some people, they aren't just like born connected to the live internet or anything.
No, definitely not.
So we're looking at how that's done now, the current methods, and also where things seem to be going, a new approach.
Exactly.
Mhm.
We've been digging into the source material you shared, and it really lays out let's call it the state of play right now, but also points towards a really interesting, potentially much better future direction for these AI agents that need external data.
So our mission today basically is to understand the common way AI searches externally right now, figure out the big headaches that this method causes,
Yeah, the pain points.
the pain points, exactly, and then unpack this newer idea that promises to make building reliable AI research agents, well, a whole lot easier.
So as you're listening, think about any AI tool you might use. Maybe it's summarizing a news article that just broke, or pulling up, I don't know, the latest stock prices, or answering a question about something that literally just happened.
Mm-hmm.
Just stop and think for a second. How does it know that stuff? I mean, it wasn't in its original training data, right?
Right.
That crucial connection, that bridge between the LLM's kind of static knowledge and the real-time external world, that's the focus.
Let's start right there with that fundamental limitation. You train a large language model, you feed it just mountains of text data.
Right. Huge amounts.
But that process, it results in a model that's essentially isolated. It doesn't have a direct built-in line to the live internet or to specific company databases or real-time APIs.
It's almost like you gave someone an incredible library filled with everything up to, say, last year, but then you locked the doors. They know everything in that library, but they can't step outside to check today's newspaper or ask someone what's new.
That's a perfect analogy. Their knowledge is a snapshot in time. So if you ask an LLM trained, a year ago about something that happened this morning,
It's clueless.
it just doesn't have the data internally. It needs a way to reach outside its own trained knowledge base.
And that's where this necessary bridge comes in, this process to connect the LLM to all that external, constantly changing information. So what's the main way this happens today?
Well, the prevailing method right now is generally called tool calling, or sometimes function calling.
Okay, tool calling. How does that actually work, like step by step?
Okay, think of it like this. You've got this sort of application layer that sits in the middle, is between the LLM and the external services you want it to talk to, like a search engine, maybe a database, a weather API, whatever.
Okay.
And this application, it's specifically built to expose those outside services as tools to the LLM.
So the application is kind of like the AI's helper who knows where to find different things.
Precisely. Within that application, the developer defines each possible tool. They give it a specific name, like web search or customer lookup. They describe what it does, and importantly, they specify what kind of input it needs, search terms, or maybe a customer ID.
Got it. So, okay, a user asks the LLM a question. The LLM analyzes the question, and then what?
So based on that query and what it learned during training, the LLM thinks, okay, this sounds like I need outside info. Maybe I need the web search tool for this one. Or, this looks like a job for the customer lookup tool. It figures out which name tool from the list the application provided seems like the right fit.
And it communicates that back to the application.
Yes, exactly. It sends a message back to that application layer. And that message typically contains the name of the tool it wants to use and whatever input it thinks that tool needs, maybe keywords it pulled from your question.
Okay, so the application gets that instruction. Then the application does the actual work.
Right. The application receives the tool name and the input. It recognizes, okay, web search corresponds to this specific Google Search API endpoint, or customer lookup means I need to run this specific query on our internal database. It formats the request correctly for that actual external service, and then it sends it off.
And the external service, the search engine or database, does its thing, finds the info, sends it back to the application.
Which then takes that data it just got and passes it straight back to the LLM.
Okay.
And now the LLM has the fresh external information it needed. It can use that data to put together its final, informed answer to your original question.
And you mentioned companies can use this for their own stuff, too.
Yeah, absolutely. This is how they can let LLMs access their private internal data. They just define their internal APIs or database queries as tools within that same application layer.
Gotcha. So, okay, the LLM itself isn't like writing database queries or making raw API calls. It's basically telling this middleman application, hey, use this tool you told me about. And the application handles the details.
Exactly. It's delegating the task by calling a predefined tool.
And this tool calling, this is pretty much the standard way it's done today. I guess there are probably frameworks and stuff to help set this up.
Oh, yeah. It's very common. And yes, frameworks exist to make defining common tools like web search a bit easier. It's a functional approach, definitely. It powers a lot of the AI experiences we interact with that seem connected to the real world.
I sense a but coming.
But yeah, building and relying on this application's translator layer, it introduces some pretty significant headaches, some real problems.
Right, and these are the things that can lead to those times when the AI just, fails or it gives you a totally weird answer that makes no sense. What's the first big issue?
Problem number one is hallucination. Now, we often hear about LLMs hallucinating facts in our answers, right?
Yeah, making stuff up.
But here, we're talking specifically about tool hallucination. The LLM, when it's trying to figure out which tool to use, might just invent one. It might make up a tool name that sounds plausible, but which hasn't actually been defined in that application layer.
Oh, wow. So it just guesses a tool name that doesn't actually link to anything real?
Exactly. So the application layer gets this request for a tool called, I don't know, find nearby unicorns.
Yeah, right.
And it has no idea what that is. There's no external service map to it. So no service gets called, no data comes back, and the AI is just stuck. It can't provide a data-backed answer. It's a complete dead end caused by the LLM just kind of going off script internally.
Okay, so hallucinating the tool name itself, that's bad. No data back. What's the next problem?
Well, even if it calls a real tool, one that actually exists in the application, it might suffer from what's called poor selection, basically picking the wrong tool for the query.
Why would it do that if the tool is, like, right there and defined?
A couple of more reasons this happens. Sometimes, honestly, it's just down to the capability of the specific LLM you're using. Some models are simply better at this function calling or tool selection task than others. A less sophisticated model might just misinterpret the query or the tool descriptions and make a bad choice.
So maybe it picks the get weather forecast tool when you actually asked about the capital of France.
That's a clear, if maybe extreme example, yes. But it's not always the LLM's fault, so to speak. Sometimes the problem is the complexity on the application side.
How so?
Imagine if the application developer exposed, say, multiple tools that have really similar names or descriptions. Or maybe you have several different databases available as tools, and they contain slightly overlapping information.
Okay, yeah, I can see that. Like maybe you have a customer database Europe tool and a customer database North America tool.
Exactly. And the user just asks, find customer Jane Doe. Even a smart LLM might struggle to know which specific database tool it should call if the query doesn't give enough context, like a location.
Yeah.
So it might pick one, maybe the wrong one. It gets data back, but it's not the relevant data for that specific customer, leading to an incorrect answer, or maybe saying it can't find them when they exist in the other database.
So tool hallucination means no data back. Poor selection means you get the wrong data back.
Got it. And you mentioned a third big issue, one more for the people actually building these systems.
Yes, and this is a big one. The operational complexity. Remember that application layer, the intermediary?
Yeah, the translator thing.
Someone has to build that. And, crucially, someone has to maintain it. The developer, the data scientist, they're responsible for defining every single tool, mapping it to the real service, handling the request formatting, parsing the response, all of it.
And I bet those external services, the APIs and databases, they don't just stay the same forever, do they?
They absolutely do not. APIs get updated, database schemas change, authentication methods evolve. If the underlying external service changes how it works.
Then the tool definition in your custom application breaks. Bingo. The definition becomes outdated. So, changes happening completely outside your system can suddenly break the connection between your AI and the information it needs. Exactly. So the complexity isn't just the initial setup. It's this constant, ongoing burden of monitoring all these external dependencies and updating your integration layer every time something shifts. It makes scaling these systems really tricky and, frankly, quite fragile.
Okay, so tool calling. It's the way things are generally done now. It works, kind of, but it's messy. It's prone to AI mistakes like making up tools or picking the wrong one, and it's a significant hassle for developers to keep running smoothly.
That sums it up pretty well.
So where do we go from here? Is there a better way emerging? What's this evolving solution you mentioned?
Right. This is where this concept called Model Context Protocol, or MCP, enters the picture. It's being developed and explored as a potential way to standardize this whole messy interaction.
MCP. Okay, what's the big idea behind it?
Well, think of it like trying to bring a universal standard connector to this world of AI models talking to external data sources. The source material used some really good analogies,
Yeah.
like how REST APIs gave us a standard way for different web services to talk to each other. Or maybe even simpler, think about USB-C for hardware.
Ah, okay. One plug to rule them all, sort of?
Kind of.
Yeah.
You can plug all sorts of different devices into different computers using USB-C, and they generally just figure each other out and work.
So instead of every developer building their own custom translator application for every single external service they want their AI to use, MCP aims to provide one standard language or protocol.
That's the core goal, yes. To create a standardized protocol and a consistent method so that any AI model can basically discover and integrate with any external tool or knowledge source without needing that bespoke developer-maintained application layer sitting in the middle.
Okay, how is it structured differently then? What makes it different from the tool calling setup?
The absolute key difference is who manages the connection piece. With MCP, the setup involves an MCP client. This is what the LLM interacts through.
Right, the AI talks via the client.
Correct. And then there's an MCP server. Now, this server is the part that connects to the actual external services, the databases, the web APIs, and so on. But here's the critical shift.
Okay.
This MCP server component is designed to be built and managed by the service provider, the company that actually offers the database or runs the search API. They are responsible for providing and maintaining the MCP server that speaks this standard protocol.
Whoa, hold on. So the company that has the data source builds the standardized connector for AIs to use, not the developer who's trying to use the data.
That's the fundamental change. It flips the responsibility for that integration piece. It shifts the burden away from every single AI developer building custom connectors and onto the service providers themselves.
That seems huge.
It is. And the interaction between the client near the AI and the server run by the data provider happens using the standardized protocol, which the source describes using the term reflection.
Reflection, what does that mean here? Not like looking in a mirror.
Hey, no. In this context, think of reflection as the server having the ability to describe itself and its capabilities to the client in a standardized format.
Ah, okay.
The MCP server can basically tell the MCP client, and therefore the LLM, hey, here are the tools or data I offer, here's what they do, and here's the exact input format I need, all using that common agreed-upon MCP language.
Okay, so the server announces its capabilities in a standard way. Like, I'm a weather API, I have a get forecast function that needs a location string, and the client and the LLM behind it can just understand that directly because it's speaking the standard MCP language.
Exactly right. The protocol standardizes that self-description and the subsequent interaction. So how does this MCP structure actually help with those problems we talked about with tool calling?
Well, I can already guess one based on your USB-C analogy. It sounds much more plug and play.
Absolutely. That's a major benefit. Plug and play. Because there's this standardized way for the client and server to talk and understand each other, AI models should be able to connect to different external services much more easily. You could potentially switch between different search providers or databases with minimal fuss, just like plugging in a different USB-C device.
Okay, that simplifies setup and makes it more flexible. What about the other big headache, the complexity and maintenance nightmare for developers?
Yeah, that leads directly to the second big benefit. A significantly reduced integration burden for developers building the AI systems.
Right.
They hopefully no longer need to write and, more importantly, maintain custom integration code for every single external tool they want to use, as long as the external service provider offers an MCP server for their service.
The standard MCP client in the AI system can just connect and talk to it.
That's the idea. The burden of keeping that connector up to date when the underlying service changes shifts to the service provider, the ones who actually know their service best anyway.
Wow. Okay, so as an AI developer, I just need my system to speak MCP using a client, and then I can potentially connect to any database, any API out there that decides to offer an MCP server endpoint. That sounds dramatically simpler.
It certainly promises to be. And then finally, how might it help with those AI errors we discussed, the tool hallucination and the poor selection? This comes down to trustworthiness.
Ah, so.
Well, because the client and server are communicating using a much stricter standardized protocol, and the server itself is providing that reliable description of its tools via reflection.
There's less room for misunderstanding.
Exactly. The chances of the LLM getting confused, making up a tool name that doesn't exist, or picking the wrong tool because the descriptions were ambiguous in some custom application layer, those chances should be significantly reduced. The standard parsing and discovery process improves reliability.
So the standardization itself helps prevent the AI from making those specific kinds of mistakes when trying to use external tools.
Precisely. It creates a clearer, more reliable communication channel between the AI's reasoning part and the external capabilities it needs to access.
This is really fascinating to track this evolution. We started with that basic fundamental need. AI needs to search external stuff to actually do research effectively.
Right.
Then we saw how the current standard, tool calling, works. It gets the job done, but it comes with these big developer maintenance headaches and these AI reliability issues like hallucination and picking the wrong tool.
Yeah, functional but flawed.
And now we've explored how this Model Context Protocol, MCP, is emerging as a potential standardized fix. It aims for a more reliable, truly plug-and-play way for AI to get external data, mainly by shifting who builds the connector and by standardizing how they talk.
It's a fundamental rethink of that connection layer.
And really, this isn't just some obscure technical detail for developers. This evolution in how an AI finds information, it's critical for the future of AI as a research partner, right? Optimizing the search strategy seems absolutely key to making these agents truly powerful and dependable.
Oh, absolutely. It's really the difference between an AI that can only tell you what it vaguely remembers from its training data months or years ago,
Yeah.
and an AI that can dynamically go out, find the most current, most relevant information from potentially any source, and synthesize it for you right now.
So for you listening to this, as you use AI tools more and more for research, for summarizing current events, for getting any kind of up-to-date info, this underlying progress, moving from messy tool calling towards something potentially standardized like MCP means those tools should hopefully become more robust.
Less likely to give you weird, factually incorrect answers because they couldn't access the right data.
Right. And easier for developers to build and improve, which, hopefully speeds up innovation too.
It's really a fundamental upgrade to how AI connects to the world's knowledge.
And that really leaves us with a final thought to chew on, doesn't it? If these standardized protocols like MCP really take off and make it dramatically simpler, almost trivial, for AI to access any kind of external data, public websites, sure, but also private company databases, specialized scientific APIs, you name it. What does that kind of widespread, easy, standardized access mean for the future of knowledge work itself? How will we discover information when AI can tap into anything so easily? How will it change how AI assists us? And maybe, just maybe, what does it change about our own definition of knowing something when access to information becomes that seamless, that integrated?